So let's take a look at this one here. Again, this one here, it says 4x squared plus 16x plus 15. Now, there's no common factor between all of them, and it's a complex trinomial, so I have to use decomposition. Using decomposition, I'm going to leave the first term the same and the last term the same. What I'm going to do is break up the middle term. I have a process to break up the middle term using product of AC, sum, and integer. So this is the process to break up that middle term. And so product of AC is 4 times 15, which is 60, and the sum is 16. So this one's pretty obvious. The two numbers are 6 and 10. Okay, if it's not so obvious to you, you got to list the factors of 60. But 6 times 10 is 60, 6 plus 10 is 16. So those are the two numbers that I'm going to break up the middle term. Positive 6x and positive 10x. People ask me all the time, does it matter which one you put first? No, it does not. If you put the 10x instead of the 6x first, you would still be factoring by grouping. You'll still get the right answer, but in a different way. Your brackets will be different than mine. So grouping the first two and the last two terms, between the first two terms, I can factor out a 2x. So I will first factor out a 2x from both of those. And what's left, this time divided by 2x is 2x, and this divided by 2x is positive 3. And then between these two things, I can factor out a 3. Actually, not a 3, a 5. So I can factor out a 5. So between those two things, this divided by 5 is 2x, and this divided by 5 is positive 3. Again, I know I'm doing this correctly because the two brackets look the same. Now, between these two things, it's this whole thing plus this whole thing. Between those two things, the bracket, the 2x minus 3, is the exact same. So I can factor out as a common factor that bracket. This, if I divide the bracket out from there, I'm just left with 2x. Divide the bracket out from there, I'm just left with plus 5. So this is the final answer. Again, if I re-expanded this, it would end up in that trinomial up there. So let's move on to some other factoring. So those are the big factoring problems. But then we got to doing factoring complex trinomials using the crisscross method. I'm going to actually come back to this in a later episode where I'll show you the crisscross method. So we'll actually skip that right now, and we'll come back to that in our notes when I do the crisscross method for you. And you'll see the crisscross method works in a different way, but you get the exact same answer. So let's take a look at factoring special products. So if you forgot special products, you definitely forgot these things. You have to understand special products. So I'll actually just pull up a blank screen here. And the first special product was a difference of squares. Now, a difference of squares. Number one, it has to be a difference. And number two, it has to be a perfect square. The numbers have to be perfect squares. Now, when we showed you stuff like this, x plus 5 times x minus 5, for instance. When you expanded this the proper way using FOIL, everything in here times everything in here, x times x is x squared, x times negative 5 is negative 5x, and then 5 times x is 5x, and 5 times negative 5 is negative 25. And then when you simplify this, the middle terms will cancel out because one's a negative 5x, one's a positive 5x. Add them together is 0. So you're just left with x squared minus 25. And this is a difference of squares. Why is this a difference of squares? Because this is a perfect square, the square root is just x. This is a perfect square, the square root is just 5. And there's a negative sign in the middle. So if you ever see something like this, it comes from two brackets that look exactly the same, except one has a plus, one has a minus. After doing so many of these, for instance, x plus 1 times x minus 1, you would have realized that there's actually a trick to multiplying these out. You already know that the middle term is going to be a negative x and a positive x, and they will cancel out. So what will be left is just the x times x, which is x squared, and the 1 times negative 1, which is negative 1. Because the middle term will be, one will be a negative 1x, one will be a positive 1x, and they'll cancel out. Again, it always ends up in a difference of squares. This is a sum and difference. Two brackets that look the same, except one has a plus, one has a minus. If you ever see a difference of squares, it came from two brackets that are the same, except one's a plus, one's a minus. So with that in mind, let's take a look at question A and B. Question A and B, if I take a look at this one here, question A, that says x squared minus 9. There's only two terms there. It's not a trinomial, it's just two terms. So then you ask yourself, is there a common factor? And the answer is no, there's no common factor. So is it impossible? No, it's not. You have to check to see if it's a difference of squares. Clearly, it's a difference of squares because number one, it's a difference in the middle. If it's not a difference, not a difference of squares. Can't do it. But there's a difference, and this is a perfect square. Square root is just x. That's a perfect square. The square root of that is just 3. So that means this came from two brackets that looked exactly the same, except one has a plus, one has a minus. Now what goes here and here, the square root of that again is x, so that's what goes here and here, and the square root of this is 3, so that's what goes here and here. If you re-multiply this out, you will get just those two terms because the middle term will cancel out. So you have to understand the difference of squares. And then question B is the same premise. If you take a look at the two, binomial, there's no common factor between the two. However, if you take a look at it, it's a difference, and this is a perfect square because the square root of this is just 2x, and this is a perfect square, square root of that is just 7. So that means this came from two brackets that look identical, except one has a plus, one has a minus, so sum and difference. Square root of that is just 2x, so that's what goes here and here, and square root of that is just 7, so that's what goes here and here. Again, you know this would be the answer because if you re-expand it, the middle terms will cancel out when you have a sum and difference, two brackets that are the same except one has a sum, one has a difference, always ends up in a difference of squares. Okay, so that should bring back some information, recall some information from you for last year. Now, let's take a look at these ones here. Again, I'm going to pull up a blank screen, but it's very important you know how to expand something that looks like this. 2x minus 3, or let's say plus 3 all squared. The way you would do this, the long way, would be to actually do this. 2x plus 3 times 2x plus 3, because 2x plus 3 squared means this bracket times itself. And then if you apply FOIL to this, multiplying everything by everything, 2x times 2x is 4x squared, 2x times 3 is positive 6x, and then over here, multiplying the 3 times 2x is another 6x, and 3 times 3 is positive 9. So, just notice what happens, and this will always happen when you have something squared. 2x all squared gives you 4x squared. The 3 squared gives you the 9. But then you will have 2x times 3, which is 6x, but you will have two of them in the middle, always. So this ends up being 4x squared plus 12x plus 9. Now it's very important you understand that a binomial squared always ends up in a perfect square trinomial. Always a trinomial. Please do not do this on a test, because I've seen this time and time again, as any other math teacher has seen. Kids see this and they say, oh, I know how to square that. 2x squared is just 2x times itself, is 4x squared, and then 3 squared is 9. But that's wrong, absolutely wrong. And I will guarantee you still people will think this is right somewhere on their test. Please do not do this. You should always understand a binomial squared always ends up in a perfect square trinomial, which is 3 terms. So, my question is, how do I go from here straight to the answer? And from your homework last night, to go straight to the answer, yes, the first term actually is 2x squared, which is 4x squared. That times itself. The last term, yes, is 3 squared, which is 9. But the middle term, how do you get that? The middle term is always going to be 3 times 2x, which is 6x. Double it, because you'll have 12x. So this is how you expand that very quickly. Okay? So how do you know that something is a perfect square trinomial? How do you know something's a perfect square trinomial? That's the other question. You know something is a perfect square trinomial, or at least you know something is weird. As soon as you see a perfect square at the front and a perfect square as the last term, as soon as you see that that's a perfect square, the square root of that, you can take the square root of that is just 2x. And as soon as you see this is a perfect square, the square root of that is just 3, there is an opportunity that this is a perfect square trinomial. Why would you want to know that? Because if you were given this, it would be better to factor this perfect square trinomial, knowing that it came from something that just looks as simple as that, rather than perform decomposition, because decomposition may be the worst method for factoring ever. So how do you check the middle term? Again, the square root of that is 2x. The square root of that is 3. 2x times 3 is 6x. Double it, it's 12x. So yes, this is a perfect square trinomial. And yes, it comes from that. What is that? It's a binomial squared. Square root of that is just 2x. Square root of that is just 3. This is embedded in doing your completing the square problems. Whenever you complete the square and you come up with a perfect square trinomial, you always end up in one of the final steps, the second last step, factoring a perfect square trinomial. So that's just a little background to knowing if something's a perfect square trinomial. So for instance this, the first thing you look at, this is 4x squared plus 36x plus 81. The first thing you always want to look at is there a common factor? No, there is not. So then you say, oh, this is a complex trinomial, so let me go use decomposition. Well, I guess, yes, you could use that. However, I noticed something. I noticed that that's a perfect square, because I could take the square root of that as just 2x. And that's a perfect square. I could take the square root of that as just 9, right? The square root of this is 2x, and the square root of this is just 9. So, knowing that, there may be a possibility that this is a perfect square trinomial. I have to check the middle number. How do you check? The square root of that's 2x, square root of that is 9. So 2x times 9 is 18x. 18x, if I double it, it's 36x. So yes, this is a perfect square trinomial. And no, I do not need to use decomposition. I can go right to the answer because I know a perfect square trinomial comes from a binomial squared. Square root of that is just 2x. Square root of that is just 9. And there's a positive sign in the middle. So this would be the final answer. If you re-expanded that, I promise you would be that trinomial there. Last one here, again, take a look at this, 9x squared minus 30x plus 25. First thing I check for, common factor. There's no common factor here. So then it's a complex trinomial. There's a 9 in front of the x squared. So do I use decomposition because it is a complex trinomial? No, I actually first am going to see if this is a perfect square trinomial because I noticed that I can take the square root of that. It's just 3x. And I can take the square root of that. It's just 5, right? Square root of that is just 3x and square root of that is 5. So this is a possibility for a perfect square trinomial. 3x times 5, 15x, double it is 30x. So guess what? This is a perfect square trinomial. I'm going to label it as that. And I'm going straight to the answer. No decomposition needed for me. So it comes from a binomial all squared. Square root of that is just 3x. Square root of that is just 5 with a negative sign in the middle because the b is negative. So I promise you that will be, if you expand that, it will be that trinomial. So again, first things, common factor always. Then take a look at what type of trinomial you're dealing with. Is it a simple trinomial? Use PSI. Is it, and you can go right to the answer, is it a complex trinomial? Use decomposition. Or is it a special trinomial? Is it a perfect square trinomial? If you've noticed that the first and last terms are perfect squares, then there's a possibility that it is a perfect square trinomial. Not all trinomials are like that, obviously. And then, is it a difference of squares? You also have to know that. So those are the four main ways of factoring. Again, is common factor, simple trinomials, complex trinomials using decomposition, and then special products such as difference of squares and perfect square trinomials.